Hi, welcome to Mathematics of Chemistry Review Part 2. My name is Dr. English, and today we're going to look at conversions. We're really going to focus on conversions between grams to moles to grams, and moles to moles. So we're going to start out by looking at gram formula mass one more time. We're going to talk about what is a mole. We're going to look at grams to moles conversions, then mole to gram conversions, and finally mole to mole conversions. So let's look at gram formula mass one more time. Now remember, the definition of gram formula mass is the sum of the atomic masses of all atoms present in a compound that represents 1 mole of a substance. The unit of measurement that we're going to use here is the gram, which is represented by a lowercase g. So let's look at two examples. I have lactic acid here, which is C3H6O3. Alright, so let's put carbon, hydrogen, and oxygen. And if we look at our subscripts here, there's 3 carbons, there's 6 hydrogens, and 3 oxygens. Then I'm going to put multiplication signs, and then I'm going to put the atomic masses for each one of these elements. So 12, 1, and 16. 3 times 12 is 36. 6 times 1 is 6, and 3 times 16 is 48. If I add these all together, I get 90 grams per 1 mole. Let's look at magnesium carbonate. Magnesium, carbon, oxygen. I look at the subscripts for each of the elements here, and I know that there's an assumed 1 here and a 1 here. And then I have 3 for the oxygens. 1, 1, 3. Multiplication signs for all of them, and the atomic mass of magnesium is 24. So 1 times 24 is 24. Carbon is 12. 1 times 12 is 12. And finally, oxygen is 16. So 3 times 16 is 48. If I add together 24 plus 12 plus 48, I get 84 grams per 1 mole. And that's a little overview of gram formula mass one more time, because we're going to need that for this next step. What is a mole? We've heard about moles. They're represented in little chemistry cartoons as little furry creatures, as we see right here. We also see a number associated with them, Avogadro's number, 6.02 times 10 to the 23rd. And if we were converting between molecules and atoms and ions from moles or to moles, we'd be using this number. But do you need to know this number for the Regents exam? And the answer is no, you don't. It's not on our reference tables. It's not in the core. Is it good to know? Of course it's good to know, especially if you're going on to take something like AP Chemistry or chemistry in college in general. Avogadro's number, 6.02 times 10 to the 23rd. But for the Regents exam, you do not need to know it. You do not need to memorize it. You're not going to use it. In the world of Regents chemistry, the mole is basically equal to the gram formula mass of a compound. An example, 1 mole of sodium nitrate is equal to 85 grams per 1 mole. The mole basically represents a large quantity of a substance. Where are you going to see the mole on the Regents exam? One, if they ask you to find the gram formula mass of something, which is equal to 1 mole. And the other places that you're going to find the mole is in really 3 different situations. If you're converting from grams to moles to grams, or moles to moles. Now, when converting from one unit to another, and this is basic dimensional analysis, I have 2 rules that I use. Whatever unit, grams, moles, whatever unit you start with, make sure that unit goes on the bottom of the first ratio. Now I use the word first because there can be situations, like if you're in honors chemistry or AP chemistry, where you might be using multiple ratios. In Regents chemistry, we never go over 1 ratio. So whatever unit you start with is going to go on the bottom of your ratio. Whatever unit you want to end with, make sure that unit goes on top of the final ratio. And again, in Regents chemistry, when we do unit conversions, we're only going to use 1 ratio. Let's look at grams to mole conversions first. You're going to be given a mass and asked to calculate the number of moles. The conversion setup is your mass. So this is the one number that will be given to you. So we're going to label that as the given. Whatever mass that is, if it's an atomic mass, you'd put the atomic mass of the element on the bottom. If it is a compound, you put the gram formula mass on the bottom. The gram formula mass or the atomic mass is always equal to 1 mole. And then mass will cancel mass, and you'll be left of moles of what you want. Let's look at an example. Convert 4.65 grams of AlMnO43 into moles. So the gram formula mass of AlMnO43 is 384 grams. I'm doing this because I don't want to take the time to go through calculating the gram formula mass because we've really already covered that. So how am I going to set this up? Well, I'm going to start out by writing out my given. That's always the first thing to do. Write your given completely, not just a number. Put the units on, put the formula on, or the element that you're working with. So 4.65 grams of AlMnO43 there times, now I'm starting with grams, which means grams is going to go on the bottom. So 384 grams of AlMnO43 is equal to 1 mole of AlMnO43. Now I know that I have done this correctly if grams cancels grams. So I'm going to multiply, then divide. Multiply across, divide down. So 4.65 times 1 divided by 384 is going to give me 0.0120 moles of AlMnO43. Now, when we talk about how many decimal places to go to at the end, you always go back to your number that's given to you. 4.65 has 3 significant figures, 3 sig figs. The numbers here are known as absolute numbers. So we don't take these into account when we're trying to figure out significant figures. So don't look at those and say, oh, that has 3 significant figures, but that only has 1. So I can only have 1 significant figure in my answer. No, don't look at these, only look at your given. So 4.65, that has 3 significant figures, therefore my answer has to have 3 significant figures. This 0 right here is a placeholder, so 3 sig figs for your answer. So again, when I look at this, I start out with grams, gram formula mass goes on the bottom, 1 mole on the top, I'm ending with moles. Let's look at another example. How many moles are in 18.5 grams of calcium chloride? Calcium chloride has the formula of CaCl2 and a gram formula mass of 111 grams per mole. Let's start out with writing out my given. So 18.5 grams of CaCl2. The gram formula mass of CaCl2 is given to me right here, 111 grams CaCl2. That's equal to 1 mole of CaCl2, writing all this out properly. And again, I know that I have done this correctly. I've set this up correctly. If grams cancel grams, I'm left with moles on top, which is what I want. So 18.5 times 1 divided by 111 is going to give me 0.167 moles of CaCl2. Let's look at significant figures. I have 3 significant figures to start with. I have 3 significant figures at the end. I'm good. Could I put a 0 here as a placeholder? Of course I can, but that is just as a placeholder. That is not considered significant. The next one, convert 8.2 grams of zinc nitrate into moles. Zinc nitrate, here's my formula, ZnNO32, gram formula mass, 189 grams per mole. Start out by writing out your given. 8.2 grams of ZnNO32, multiplication sign and a line. I'm starting with grams, so grams is going to go on the bottom. 189 grams ZnNO32, that is equal to 1 mole of ZnNO32. This is set up correctly because grams cancels grams. You should always be able to cancel down and to the right. 8.2 times 1 divided by 189 will give me 0.043 moles of ZnNO3 2. One more time. How many significant figures am I starting with? In this case, I'm starting with 2. 2 significant figures. Therefore, when I put this into my calculator, I want to round to 2 significant figures. So this is not what shows up in my calculator when I do this. It tends to be a much bigger number. But again, I'm trying to be specific about this. 2 significant figures to start with, 2 significant figures to end with. Now let's look at moles to gram conversion. So we're going in the opposite direction. So in this case, we're going to be given moles and we're going to calculate the mass of the substance. So find grams. The conversion setup here is you have a given number of moles. 1 mole will go on the bottom. The gram formula mass, GFM, will go on top, or the atomic mass if you're just dealing with one element. And you will end with mass. Let's look at our first example here. Find the mass of 5.2 moles of water. So here's our formula for water, H2O, and it has a gram formula mass of 18 grams per 1 mole. Start by writing out the given completely. 5.2 moles H2O, multiplication sign and a line. If I start with moles, 1 mole on the bottom. 1 mole of H2O. Water has a gram formula mass of 18, as I have listed right here. 18 grams of water. And then I double check. Moles cancel moles. I'm canceling down and to the right. 5.2 times 18 divided by 1, and that's going to give me an answer of 94 grams of water. When I put it into my calculator, I believe I get 93.6, but again, I'm starting with 2 significant figures. I need to end with 2 significant figures. Let's look at more mole to gram conversions. So find the number of grams in 11 moles of ethanol. And here's our formula for ethanol right here, C2H6O. And the gram formula mass for ethanol is 46 grams per 1 mole. So we're going to start out by writing out our given, 11.0 moles of ethanol, C2H6O, multiplication sign and a line. And if we're starting with moles, it's 1 mole on the bottom. And our gram formula mass is 46 grams. Moles will cancel moles. 11 times 46, and that is going to give us 506 grams of ethanol, C2H60. The only sticking point here that people might have issues with is if they look at ethanol and they see it as C2H6O. That's a condensed formula of it. It's just listing all the carbons, all the hydrogens, all the oxygens together. Some of you might recognize ethanol as being an organic alcohol and be used to seeing the formula as C2H5OH. That's fine. That is ethanol. It's just the hydrogens in this particular form had been condensed together. So it's not an issue. The gram formula mass is going to be the same, but I wanted to bring it up. Let's look at our next example. How many grams are in 0.02 moles of calcium? So now we're just working with a single element. 0.02 moles of Ca, multiplication sign and a line. In 1 mole of Ca, there are 40 grams of calcium. I want to make sure that everything is set up correctly. Moles cancel moles. 0.02 times 40 will give us 0.8 grams of Ca. If I look at this here, I have 1 significant figure, therefore my answer will have 1 significant figure, and everything is canceled out, everything is labeled correctly. I'm good. Finally, let's talk about mole to mole conversions. The big thing that you need to know about mole to mole conversions is that in no way, shape, or form do you need to find the gram formula mass. We're converting from moles of one thing to moles of another. When you see these types of questions on the Regents exam, they will always give you an equation and it will always be balanced because the concept that they're testing you on is if you can convert from moles of one thing 2 moles of another. That is the skill. So what are we doing here? Well, given moles of one substance, we're going to calculate moles of a new substance. We need to know that the coefficients in a balanced equation are going to represent our mole ratios, and the ratios have to be maintained. In other words, you can't change the numbers that appear in this balanced equation. If I look at this, I have C3H8, which is propane, plus oxygen gives me carbon dioxide and water. There is an assumed 1 here that we need to be aware of, so it's a 1 to 5 to 3 to 4 ratio. This question asks, how many moles of water will be produced from the complete combustion, because this is a combustion reaction, of 0.5 moles of propane? You need to know that propane is represented by this formula right here. If you don't know that, well, you need to go back and review your organic, because that's going to be pretty critical. I'm going to start out by writing my given. 0.5 moles of C3H8. Multiplication sign and a line. Now whatever unit I start with, I'm going to put on the bottom of my ratio. Moles of C3H8. And what do I want here? I want moles of water. Moles of H2O. Now I go to my balanced chemical equation and I look at the coefficient. The coefficient in front of water is 4, so we're going to have a 4 on top. The coefficient in front of C3H8 is 1, so we're going to have a 1 on the bottom. I know I have set this up correctly. If moles of propane cancel moles of propane, which they do, 0.5 times 4 divided by 1 will give me 2 moles of water. So incredibly important to know that gram formula mass is not used. You need an equation. It needs to be balanced correctly. Then you need to look at your mole ratios. Let's do some more examples. What is the number of moles of oxygen molecules consumed when 3 moles of methanol molecules is consumed according to the equation above? Now the word molecule is in there to distract you. We're not using Avogadro's numbers. We're not actually converting to molecules themselves. We're looking at moles. So this is moles of oxygen and moles of methanol working together. Let's find our given. 3.0 moles of methanol, and here's methanol right here with a coefficient of 2. So CH3OH, multiplication sign and a line. I'm going to put moles of methanol on the bottom. What am I looking for? What is the number of moles of oxygen? So I want moles of O2 up on the top, and then I look for my coefficients. I look at my balanced equation. There is a 3 in front of the oxygen, 3. There is a 2 in front of the methanol, 2. Moles of methanol cancels moles of methanol. I want moles of oxygen at the end. 3 times 3 divided by 2 will give me 4.5 moles O2. 2 significant figures to start with, 2 significant figures to end with. I'm good. One last example. 2 moles of carbon monoxide react with oxygen to produce 2 moles of carbon dioxide. So what does our question ask? What is the minimum number of moles of oxygen required to produce 1 mole of carbon dioxide? No matter what the wording is in these questions, just pay attention to the numbers that are given to you. Our given is 1 mole of carbon dioxide, 1 mole of CO2, multiplication sign and a line. Moles of CO2 are going to go on the bottom. What is the minimum number of moles of oxygen? So I want moles of O2. I look at my balanced equation here. There's a 1 assumed right there, so this is going to be 1. There is a 2 in front of the CO2, and I have to be really careful. This was done on purpose. The CO and the CO2, even though they both have the same coefficient, look very similar. So you have to take your time and make sure that you're using the correct coefficient if there were different coefficients here. So be careful, just as a warning. Moles of CO2 cancel moles of CO2. 1 times 1 divided by 2 will give me 0.5 moles of O2. 1 significant figure to start with, 1 significant figure to end with. Everything checks out. Let's look at this last example. What quantity of carbon monoxide is required to react completely with 2.5 moles of oxygen? Now, they don't really specify what they want here. Do they want grams? Do they want moles? But since we're on a mole-to-mole kick, let's just find moles. 2.5 moles oxygen, multiplication sign and a line, that's my given. Moles of O2 on the bottom. What do we want? Quantity of carbon monoxide. Moles of CO. I go to my balanced equation. There is a 2 in front of the CO. 2. There's an assumed 1 in front of the O2. 1. Moles of O2 cancels moles of O2. 2.5 times 2, that would be 5 moles of CO. I go back, I check, I make sure that everything is set up correctly, I make sure that my math is done correctly, and I'm good. So what did we learn in this review? Well, we went over gram formula mass one more time. We talked briefly about what is a mole. We looked at some gram to mole calculations. We looked at some mole to gram calculations. And then finally, we looked at mole to mole calculations. Need more help? Feel free to contact me. And as always, I'm looking for feedback. Thanks so much and have a great day.